let's say this whole activity you have already understood. So initial part, we start with the discovery, then we go for the delineation, and followed by development activity. So more or less I have dealt this topic earlier also. So in the process, actually, what after discovery or before discovery also, we gather different information in a different scale. Okay, so this scales, once we just
Sir, I cannot see the screen.
you cannot see the screen.
No, sir, no.
Oh no, so okay. Stops here. Let me. Okay, so now it is visible.
No, sir.
No, sir.
Okay, stop sharing.
Okay, done, sir.
Now it's visible.
Yes, sir.
So in this present context, what we, if you just see, whenever we are planning for any data, we need to plan it very early and well before the acquisition time. So, and we need to acquire the effective data. So an effective data acquisition and analysis program requires careful planning and the ongoing well coordinated team efforts of geoscientists and engineers. So what we have seen earlier, right from the drilling activity, we started acquiring different parameters for data. Once you see, when we are drilling, we try to collect the whole core data, and also during the drilling time we collect the mud logging informations, isn't it, by the geoscientist. So that actually help, that is actually the initial part. So what, before we acquire the data, we require the planning, data collection, justification of data, then timing of data collection. Because if you see, if you wanted to collect a whole core, and if you drill that zone, so you won't be able to collect it. So well before, you need to give the requirement, so that okay, I want to collect an whole core samples from this zone. Okay, then you need to prioritize also. Prioritize means each and every case we need to see. Then you see this part I have already shown you. So we collect data in different scale. One is microscopic, then you have your macroscopic, megascopic, and gigascopic. All scales we gather information, but as a geoscientist or engineers, our role is to gather data in different scale, but we need to sometimes upscale or put the information in the whole reservoir scale. Okay, so this is our responsibility. Okay, so you have already understood regarding the fluid part, the core part, and the logging part. You have already undergoing this course. So you see the WTA, well test analysis, isn't it? And you have studied the seismic part also. So this part is completely missing in your part. So that's why I thought, yeah, I'll put. So what active well test is and how it substantiate or maybe put complementary information in regarding the reservoir. So this is an important. So far we have discussed about the logging, then you have crude oil data as well as the core data.
Sir, check the message in group.
Okay, okay. So I don't know, I have, let me just manage participants. I allow everybody to, those actually invite, whom to invite. So what are the problems going on? I don't know. Means, are they could not join what they are saying. Okay. Ali and Suman both are writing, but okay. So the old information will not be valid, na? They know that. Hello.
I don't know, sir.
Okay, just you have the password and na?
ID. Yeah. I will send it again.
The last one, last year. So because I have changed it na last time.
Yeah.
Okay, so that may not be having. So you. No password and meeting. Suman is giving wrong information actually. Okay, so who joined? Suman or Ali? Somebody joined. Hopefully 4 are there. So okay, so hopefully they will
No,
join.
sir.
Huh? But it is showing
Only
4.
me and Shreya. Sir, I can see only 3 of us. Me and Shreya.
Yes. Yes.
But
Sir.
here it is showing. Yeah, he is on. Your Abdul. Abdul is one person is waiting. Admit. Okay. Okay. I don't know how to.
Yes,
Okay.
Abdul is there.
Abdul
Sir,
is there.
Abdul is here.
Yeah. So maybe Suman was using the old information hopefully. Okay, so in this context, well test analysis is what actually a well test analysis. Okay, so well test analysis. Let's say if I just go through this slide again, if you see we have the dynamic information. If you see in just with a few yellow circle, if you go initially geology, seismic, logs, petrophysics and dynamics, just it is in pink, more or less pink color, slightly more than that. Okay, so that these are the informations put together. So when we got this information, the dynamic information, when so what is happening, if I just try to brief you how the things are happening, we start drilling a well. Okay, then we go on drilling continuously, and in between we collect the core plug samples as well as the fluid samples by modular dynamic tester. Then we complete the well, last target depth, and case the well. Then we perforate the well. I'm just grossly I'm saying this, not going into in the details of the. Then we perforate. Okay, so once we perforate, then this well is activated. Either stimulation or activation job is been done. Then this well has been handed over to the bottom hole party, or you can say the reservoir people. Okay, so actually this well test generally done by the reservoir people in most of the cases. And how? So this is the very first time we are trying to get the PI of the well. PI means the initial pressure. Oh, initial pressure we try to measure. So if you just see on this slide, if you see, so many informations are provided. So many information means, you see, so we are getting particularly the dynamic information of that. Okay. So these dynamic informations are actually the well test. And how we get it? To generate data from bottom hole reservoir, we initially do the pressure measurement. Then we continue the bottom hole sampling. I have discussed this time, if you remember last class also. Then this is now this part, pressure measurement and bottom hole temperature, we are now going simultaneously for with the help of electronic memory gauge. Okay. Then we go for sampling, bottom hole sampling. Then if everything fine, then we go for the pressure transient analysis. This is called well test analysis, or well testing, transient well test. Why it is transient? I will come one by one. Okay. So have you understood this, the sequence of operation, how we do it? Okay. So that means once we complete a well by drilling up to the target depth, we lower down the last casing. Okay. So before that we have done, you know, the wireline logs also. We could do the modular dynamic tester, because modular dynamic tester is your open hole. Okay. So then we case the well, and then we stimulate to activate, perforate and activate. Then we go for the pressure measurement. Simultaneously we measure the pressure and temperature with the electronic memory gauge. Then we collect the bottom hole samples for our PVT study, and followed by pressure transient analysis. This is the well test analysis. Okay. So if I just go to the graphs, next slides, you see this is the setup. Okay. So if you see on the top, you can see the drilling rig is still there. Okay. Then you have all the mud pits and all the drilling arrangement are still there, and that time this well is given to the bottom hole people, or maybe you can say the reservoir people mainly. Okay. In ONGC structure, this is to the reservoir people mainly. Okay. Even if you just consider, we have here in Ahmedabad, we have Ahmedabad Asset as well as ONGC IRS. IRS people are not doing it. Okay. But the asset people, actually in asset also there is subsurface team. Through subsurface team the people are doing. There are many reservoir engineer. Okay. So our director, present director now, he was once subsurface manager here. Okay. He was actually leader. After asset manager, there is two manager, actually subsurface manager and surface manager. Surface manager is taking the lead role of the production part, and subsurface manager is taking the lead role in the subsurface activity. Okay. Subsurface activity means the sample collections, then you have a well test analysis also, all in the part of their job. Okay. So have you got this arrangement? So how we, so now this particularly, this is a winch van. Okay. Similarly, during logging also you have this van that is called logging van or logging truck. Okay. Same type of truck. So I'll just go next slide. So these are the
sir, well testing is done before casing and cementing, right?
No, it is generally, because you see generally what well testing is done after the casing and stimulation. Because why we test? We try to get the dynamic information around the wellbore as well as skin also. I'll come to that one by one. So what we do, we case the hole, last casing. Okay. Then we perforate the zone of interest. Then we activate it, because sometimes even if you perforate, nothing will come to your well, because you may have some skin which is not allowing to communicate the reservoir fluid to come into your well. Okay. So that's why we do the well test generally after the casing, perforation and activation. Activation means once the fluid entering into your wellbore, that time you can do it. Okay. Clear?
So while production we can do the well testing.
Yes, that is different types of well testing are there. You can see this is flowing bottom hole study we can do static bottom hole study. I will come one by one. Okay. So once we lower down the instrument, so these are what? These are actually your different requirements you need to carry with you when you are going for the bottom hole operation. Okay. So bottom hole winch van, this is a truck actually. Okay. Winch van means there is a winch where you can keep your wear. Okay, then pressure recorder, temperature recorder, clocks, pressure chart, chart recording, microscope. So when I worked with this industry, that time I use all this. Now you have electronic memory gauge. Okay, the electronic memory gauge. So I'll come to that little afterwards. Then we have winch wear, winch having wear, so that your required things should be lowered down through the help of a wear. Then you can have the bottom hole sampler, high pressure fluid sample bottle. These are what? These are for collecting your fluid samples. Okay, last class I discussed, not last class, last class. Okay, then you require calibration set. You require a lot of instrumentation, basically a range. Then you have your settings. Then dummy manometer. Why dummy manometer is required? Dummy means scrap manometer, which already you cannot use it. Already scrap manometer. We generally, before doing any study, bottom hole study, we go for dummy operation. Dummy operation means a false operation where we lower down our dummy instrument up to the desired depth of operation, so that we could not lose our actual instruments when we will be doing that. So that's why dummy operation is must before doing any sort of downhole operation. Okay, then you can have a Bela sampler, just like a bucket. You lower down and take some samples. Okay, just normally. Then you have this well head assembly. I'll show you afterwards. Then complete toolbox, precision master gauge, and light vehicle for emergency measurement. So you see, when you are going for the field, you have your winch van, but you should carry one emergency vehicle always when you are in the drilling rig or you are going for operation. This is a must. Okay. So as an engineer, you should be very careful about at least keeping something in mind. What are the things? One, before doing your bottom hole operation, you must run your dummy sampler or dummy gauge, so that you should know your well is clear up to a certain desired depth of study. Number one. Number two, your operation should be accompanied, or all the vehicles or the people should be accompanied by a light vehicle for emergency purpose. This is the most important part. Okay. Then you need to carry other instruments for your own study, because you are technical people. You should know when you are going for, and as a responsible engineer, you should carry, or you should know all the information of that specific well before going to the well site. Okay, so is it a producing well, or is it workover job has been done, or what is the status of the well, what is the drill depth, what is the casing shoe level, where is the perforation done, what is the current things happening into the well. So everything you should know before going to the field site. Okay. So because you see, you will be a responsible engineer, but all other people will subordinate staff. They may be driver, they may be some fitters, they may be some electrical people. So they are only the subordinate staff. So you should know what to do before going to the field. Okay. So next is your, this is the set. If you see left side, you have your up to lubricator crown valve. Okay. This is already there in above your well. This is well head assembly. So if you see above the lubricator valve, it is all you need to carry. Okay. So the track also, as well as the pulley and the lubricator pulley, the lubricator, everything you need to carry. Okay. So have you got this arrangement?
This is coil tubing.
No, it's a similar type, but this is different. I'll just come, I'll show you the whole picture so that you understand what is happening. So what the top side, what is there in the right top corner, it is lubricator assemblies, that cap part is given. I'll explain you afterwards. Okay. So have you got it? Just like pulling a bucket from a well, having pulley. Got it?
Yes.
All of you hopefully taken out water from a well, normal well in the village or any place. Have you seen that, how people take out water?
Yes, sir.
Same
Yes,
thing.
sir.
Yeah.
Yes, sir.
Same,
Handling.
yeah, same thing. We need to keep our vehicle at a certain distance so that the slope of this winch wire should not be so high. Generally 20 to 25 meter we keep it, because depending on the well head and your lubricator, the height is more. So you need to put your track in such a distance. Number one. Okay. So now the next slide will show you some other information. So this is the, you see this part you need to carry. So you have lubricator. What is lubricator? Lubricator is the, you see from the, if you just, I go back the, sorry, go back the previous slide, you can see above the lubricator valve, whatever arrangement is there in a rod form, that is our lubricator. The whole length is lubricator. Above lubricator, we add the lubricator pulley. Okay? Pulley. Yes. And you see the lubricator cap is there. Lubricator cap is expanded in the right side figure, which is there. And that is actually controlling all of your pressure. I'll come one by one. Okay, so we are fixing it like this. So lubricator is made of 2.5 inch tubing with a male tapering thread at both ends. Okay, the length of the lubricator may vary from 1.5 to 2 meter. In the upper part of the lubricator, a needle valve is fitted to which a pressure gauge is fixed. You can see here a pressure gauge, needle valve is there, and a master gauge, a pressure gauge is there, isn't it? So the lubricator is the whole length. Inside that, we need to put our manometer. If you see in this there, you have a lubricator which is actually the outside pipe, which is we need to fit on the top of the master valve. Okay, then we need to what, how we have to arrange. I'll come to the next slide how to put it. So this is actually above crown valve, in the place of bull plug you are just putting your lubricator. So your fitting is first the lubricator, then you are attaching a pulley here. So now you are attaching a pulley, isn't it? So got it? So you see pulley is also attached with a L sort of thread pulley. Okay, so this is length, rod is your lubricator, and you are attaching a pulley so that where you can lower down or pull in properly. Okay, so then this is a lubricator cap. If you see the detail of the cap, you see the winch wire is passing through the cap, isn't it? And cap is what a cap, you see on the top is a cup nut. Okay, so you and you have a iron thread, this solid iron block. Yeah, so that is not sort of things you can, and inside that you have a rubber packer. Okay, there is a small hole to the rubber. It's just like a rubber through which a hole is there. You can lower down your winch. You cut the winch wire and put it there, and then tight the nut so that the rubber will be squeezed and hold your wire in a very tight manner. Have you got it? The idea?
Yeah.
Okay, so you have a, you see you have a this nut. This nut is just like a threaded nut, and below that you have a rubber packer, and all through there is a hole through which you are you are just inserting your wire. Okay, winch wire. And how you tighten it? You just tighten the nut so that the rubber packer will be squeezed and it will hold the wire in a very tight form. Okay, so this is actually the main supporting part for your whole pressure, because when
Sir, what is the function of nuts?
nut is actually tight, you are tightening a nut. When you are tightening a nut, you see below that you have a rubber packer. Okay,
Yes.
that rubber packer actually squeeze. Okay, squeeze means it will squeeze and hold the wire in a very tight form. That is the only pressure you can hold. Because if you loosen it out, then it will, because you are now opening your main master valve and you are attaching with your lubricator. Okay, so this is the main part which actually control your pressure and control your blast also. If you make it loose, then it can blast like anything.
Loss of pressure. Okay.
Yeah, a lot of pressure is there. Okay, so this is how. So you understood, huh? So now you see, I'm just going through the slides. A hole of 25 mm diameter having threads is made at the center of the solid iron block, so to accommodate rubber packer of 1 to 11 1 by 1 2 inch length. On top of the rubber packer, a nut is fixed at the center for allowing the winch wire of diameter 1.6 mm to 2 mm to pass through it. By tightening the nut, the rubber packer will expand and ensure good sealing. Only this rubber packer, with a tight tightening of this nut, it will only squeeze and hold the wire in a strong. So now this pulley. So now this is your attachment. And once you lower down through the pulley as well as through the lubricator cap, you are now putting your manometer into the top of your wire. Okay, just just like how we do our or how you knot our bucket behind the pulley. So initially you pass through the pulley, then you knot the bucket, but before that you cannot. Generally, what we do, we pass the wire through the pulley first. Here, two things:
Yes.
pulley and lubricator cap both. We are passing the wire through both, and then we are we are knotting particularly making the knot with the manometer. Okay. 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 Now next part is this part. So once you fix lubricator is fixed on the crown valve, all the valves, master gate, middle gate, crown valve, all valve, you are what? You are closed when the SBHP is to be recorded, is to be. So that means when you are already there, that means you open the valve and try to connect it. Okay, so this is once you see.
Yes.
Okay, so now this is the wire is passing through, then this is the lubricator cap, the lubricator here, so wire is going through, and then you are just making the knot with the manometer. Okay, clear? Okay, so we have 10 minutes left. Okay, the wire
Sir, is here Christmas tree? Is it available in the photo? Christmas.
yeah, you see below that in the diagram.
Yeah. Okay.
Below that. Okay, so this is what the arrangement is. Okay, so now the wire is taken through the cap on the bottom hole equipment, and a loop is made. The cap is firmly fitted to the bottom hole equipment. The instrument is kept in the lubricator resting on the crown valve. So now if you see this manometer, we need to program it. I'll tell you the manometer is already we have programmed it. That means it is recording the time. Okay, time and pressure as well, because once we switch on the manometer or program it, at what time it will start recording. So this work we are doing, and that time manometer is still on. Okay, the manometer or electronic memory gauge. It is not manometer now; it's an EGM, a EMG, electronic memory gauge. I will come to that. Okay, so then you see the whole system. So this wire is along with the winch wire. It is now connected. Fine. Okay. So
Yes, sir.
now you are putting depthometer 0 by putting because some measurement depth measurements are there. You are putting your depthometer 0, and this is now you open all the valves so that this valve, lubricator valve, all the valves, so that your instrument should go down. Are you getting the point? So right from the top you are now lowering down your instrument. Okay.
Yeah.
Okay, so this is the equipment is lowered slowly. Initially, the lubricator cap nut is loosely fitted to sustain the pressure. So now what you do, somebody should go to the top. If you just try to see the arrangement, then you can understand. Okay, so somebody to stand there and just open this nut. Okay, it's very tough actually. It's very risky because you are in a boom actually. Okay, then you are opening all the valves. Okay, slowly you are opening the nut so that the wire should go through. Otherwise, if your nut is tight, then the rubber packer will hold the nut very tightly. So that's why slowly you are lowering down. Okay, so got the arrangement of how you do the. Then now we will be going to the lowering down our instrument. If you see, in this way we are lowering down our equipment. So the equipment has to be lowered up to 10 to 20 meters above the tubing. So initially we go for dummy operation. You agree? It's not the two electronic memory gauge lowered down, because we don't know how much up to below it is clear. So that's why dummy operation is a must. Okay, so dummy operation. Then once you are very much satisfied with the dummy operation, okay, this, my dummy has been gone up to that depth of my measurement. Now you lower down your equipment up to 10 to 20 meters above the tubing shoe as a precautionary measure. Okay, then the last 100-meter depth should be lowered with great care and with extremely slow rate. You cannot be very fast. I will come to that in which rate you have to lower down your instruments. Okay, so up to now it is clear how we are going to the field with the field party. You may not have any sometimes, but we never know. Sometimes we may have to go also. Okay, so after the desired operation is over, I will. So desired operation is over means I will hold the testing part. We'll discuss afterwards. Okay, it may be just a sampling, it may be a bottom hole pressure and temperature survey, it may be a transition well test for 5 days or maybe for 10 days. Okay, so then once we finish our operation, the equipment is pulled out manually for the first 10 meters and then with the engine at the safe speed. The last 100 meters should be pulled. Why this last 100 meters should be pulled out very slowly and the last 10 meters should be pulled very out manually? Can anybody tell me? Because once you are lowering down your instruments with a wire, the wire can change its length, isn't it?
Yes.
Your depth may not be very much accurate, so that's why you should be very careful. Otherwise, if you using your instruments very or maybe instrument is there and you are pulling through your engine speed, so it can tear. Once it has been come to the end, it may tear out. So
Yes.
your instrument may fall down. So that is how
Fall down.
Yeah, so that should be very careful. So that's why these are the few basics you need to follow. Okay. So now again, when the instruments is lubricator, okay. So these are few actually how to do. Okay. So this is what now we have. Okay. Equipments for bottom hole pressure measurement. So this is just an initial idea so that you understand what as an engineer we have to do. Okay. So now dummy. You see, we are now taking one dummy instruments, isn't it? Scrap instrument, so that we should do our dummy operation. Then second part is, you see, bottom hole. When I work, we use bottom hole pressure study for manometer and bottom hole temperature study. But now with an electronic memory gauge, it is now you have to only one instrument, and you have the bottom hole sampler. Okay, that we have discussed also, bottom hole sampler. Okay.
Sir, what's the meaning of dummy actually?
Dummy actually any scrap things, so that generally what people do.
Not in working condition.
Yeah, not it is just to see that your downhole depth is clear or not, because you see in the well so many problems you may encounter. Let's say in between your wax has been deposited, you don't know. If you lower down your instrument, sometimes the instruments go down and it has been attached to the wax and you cannot pull it up afterwards.
Okay.
So that's why we try to see the desired depth of operation, is it clear or not. Okay.
Okay.
Dummy means just a extra work you have to do to see or to take the precautionary measure, so that once you should not lower down your costly instrument in an proper or maybe in a hole where it is not very much clear or maybe problematic well. Okay. So every time it is happening. Okay. So electronic memory gauge now. So present technology, you have the electronic memory gauge. Now this is what temperature sensor. Okay. So this is what measurement of the resistance of 2 wires of platinum glued on a ceramic. So it would be completely sealed instruments. You may not see the instruments. You cannot also, because it is already the whole circuit. You will only see a rod. Okay. And inside you have everything. This is one which is this is mechanical gauge. Initially we have when I worked that time we used the Umbrella 3, Umbrella 4 gauge. That is mechanical gauge. It is nothing but what, once the pressure will build up here, the spring will rotate and will record the pressure. Okay. So that is actually the manometer. I'll show you what I have used the diagram. Okay. Here. This is actually, you see this is a bellow. Okay. Bellow, where if you pressure is increasing, this helically coiled Bourdon tube will rotate and it will mark here. Okay. This mark, it is actually a holder where a carbon 5 inch by 2 inch carbon chart has been there, and this clock is actually a mechanical clock, just like initially our clock, table clock, isn't it? So you give the spring rotated, and with time the spring will open up. I use this. Actually it is not no more now in the industry. So it will lower down the chart and it will mark. How it is marked? When the pressure will increase of this bellow, the spring will uncoil and it will mark in the carbon chart. Okay, so that is actually if you remember some whistle, we just the small kids blow. If you give a blow into that whistle, something will uncoil and po sound is there, and again it will coil. Yeah, so
60
this is,
lakhs.
yeah, so these are boron tube actually. Okay, mechanical gauge, and now it is no more in the industry. So this is how it marked, and that gives us the pressure, particularly pressure value. I'm not going it because it is not in the industry now. I'll just show you. So industry is now having this sort of things. This piezoresistive mineral and piezoelectric mineral, quartz, piezoresistive sapphire, these are actually now used. Okay, so just giving you a broad idea. So this is sapphire sensor, Schlumberger sapphire sensor. Here, if you go to the below black part, this is a vacuum box is there. Okay, and they are actually recording your pressure and temperature once you program it as you program it. So I'll just show you next diagram actually how it records. Okay, actually this is recording the vibration of your piezoresistive mineral, and it is recording pressure temperature values. Okay, okay, so clear.
Yes.
Okay, so this is
Yes, sir.
this is recording. That means once you lower down, it is recording. This is the whole quartz-joint crystals, how it has been there. The whole actually within the tube, this whole instrument has been properly packed. So you have a reference sensor crystals, reference crystal through which the pressure and temperatures are measured, and actually